Hi, Assalamualaikum warahmatullahi wabarakatuh. Today we'll be doing some reinforcement exercise regarding 4.4 intermolecular forces. So this is part 1 of the video. Let's get started. So for exercise 1, we need to explain the van der Waals forces and give its type. Also, we need to explain how the atomic size or the molecular size can influence the strength of these forces. So, what is van der Waals forces? So van der Waals forces are basically attractive force between the neutral molecule. It has two types of van der Waals forces, which is dipole forces and London dispersion forces. So how does we relate that with the molecular size? So when the molecular size get bigger, the number of electrons get higher. This results in the formation of a bigger electron cloud. So the valence electron will be further away from the nucleus. Hence, the electron can be distorted quite easily. The polarizability will get higher, and hence the strength of the van der Waals forces increases. For the second exercise, the table below shows the melting point, boiling point, and the solubility in water and the tetrachloromethane, which is an organic solvent. Okay, as what you can see here, for compound E, it has a very high melting point, boiling point, very soluble in water, and very low solubility in the tetrachloromethane, which is organic solvent. For compound F, melting point is very low, same goes to boiling point, and also very least soluble in water, but then very soluble in CCl4. So we need to determine the type of compound for E and F, and also explain why the boiling point of E is higher than F. Also, for part C, we need to explain why E has a very high solubility. So let's start. So basically, compound E is an ionic compound. So it is a polar compound. But for F, it is a simple covalent molecule, which is non-polar compound. So ionic compound E is formed by the electrostatic forces between the positive ion and the negative ion that attract one another. But for F, it is a simple covalent molecule, where it has a van der Waals forces between them. And this explains why E has a higher boiling point than the van der Waals forces. And C, E has a higher solubility in water because basically E can form polar bond with water through its anion and cation. That's why in ionic compound, for example, NaCl is an ionic compound, right? So if you dissolve salt in water, you will get a salt solution. And this is why polar compound can dissolve in polar solvent, which is water. For exercise number 3, we need to give the factors that influence the strength of the van der Waals forces. As you know, there are 3 factors that influence the strength of the van der Waals forces. And then, for the second part of the exercise, you need to compare the boiling point of H2O and the H2S based on their intermolecular forces. So let's get started. So there are 3 factors affecting the molecular size. There are 3 factors affecting the intermolecular forces, which is the van der Waals forces. First is molecular size, second is molecular shape, and third is molecular polarity. So the boiling point of H2S will be lower than H2O because H2O basically only has the van der Waals forces. Meanwhile, for H2O, it has hydrogen bonding. And as you know, hydrogen bond is a much stronger bond than the van der Waals forces. Hence, more energy is required to overcome the strong hydrogen bond in water than weak van der Waals forces in H2S. The H2O has hydrogen bonding because the hydrogen is attached to oxygen. So hydrogen bonding can only exist when the hydrogen is formed either with oxygen or with fluorine or with nitrogen font, as in your lecture note. Alright. Next, for exercise number 4, by referring to the butane, propanol and propanol, explain the type of intermolecular forces in this compound and the relative boiling point among those compounds. So in order for us to answer this question, you need to know the structure of these 3 species. So for butane, you will have the structure is something like this, which is an alkene compound. So for those in PST, you have seen this in your secondary school, where alkane is a hydrocarbon compound, and propanal is an example of aldehyde. So it has a structure of something like this, with oxygen attached with a double bond with the carbon. Meanwhile, for propanol, as what you can see, there is a hydroxyl group, which represent an alcohol group. Okay, this OH group basically can form hydrogen bonding with another molecule of propanol. But here, for propanol, you cannot form hydrogen bonding because hydrogen is attached to the carbon. So in order for you to form hydrogen bond, the hydrogen must be firstly attached covalently with oxygen or with fluorine or with nitrogen bond. Okay, so let's explain this exercise. So as what you can see, in butane, it has only London dispersion forces. Meanwhile, in propanol, because there is present oxygen atom, the oxygen is very electronegative atom, and therefore there is a difference in electronegativity. So we can say that it is a polar molecule, and hence it has dipolar forces. Meanwhile, for propanol, it can form hydrogen bonding. So in terms of boiling point, the propanol will have a higher boiling point than propanol than butane, because hydrogen bond is much stronger than the van der Waals forces, where the London dispersion forces is weaker than dipolar forces and much weaker than hydrogen bonding. Okay, that's all for part 1. See you in the next video. Bye.